Welcome to Turn Right Machine Works. My name is Keith, and today we have a project. We're going to be drilling and reaming out the bores to hold the main stem and pintle shafts for bronze rudders. And this is going to be the small rudder we're doing, and this is a single stem rudder, meaning it only has one stem bore and one stem installed. We're going to drill and ream these for a press fit for these shafts to fit extremely snug and lock the blade to the shaft itself. All right. The other blade we actually have two. One's a little smaller than this, but this will give you an idea. We have a bore going in the top here, and the pintle is a pivot for the bottom. It's a support that comes from the skeg, from the lower part of the hull. It'll come down here and it'll grab a hold. It'll have a bushing or bearing, and that stables the lower section of the rudder. So anyway, we're going to be putting in these bores. Now, most of the time when you have a blade or you have something that's long, slender, skinny, it's very hard to hold it and drill and ream it. And in this case, keep this bore and shaft perfectly in line with the pintle. You can't, I mean, rudders do not spin all the way around, but they do a pretty good degree of pivoting from side to side. And if this pintle support down here was not in line with the upper shaft, you would have binding in your system, and you would probably have an easy spot, but then when you go to crank it one way or the other way, you're going to have such force on that rudder, it's going to be hard to turn or lock it up. Now, I've rotated the head around on my K&T, and I'm actually going to use it horizontally like a HBM, and that's one of my favorite machines. I've mentioned that over the years, but I don't have one. And actually, the latest one that I really see that looks like a pretty machine there is the one that Bruce Whitman has over there in Australia. But I'm not that fortunate. I brought and made this jig several years back. When I started doing all of these rudders, I needed a way to hold them, rotate them around, and keep the alignment from hole to hole on the doubles. Also, to hold the rudder in line with the hub that the shaft goes through, and hold the rudders in the right position, the right parallelism with the shaft itself, so that they're not angling off or they're not in any other direction than they need to be. This jig mounts on the end of the table here, and this is the bottom side here. The first thing that I have is a 3-inch box tube here, and that box tube is the main straight support for the jig itself. I put 2 angles on each side so that I could pick up these 2 outer T-nut slots with using the T-nuts and dropping straight bolts down through here. The center slot I machined through the box tube, and then turned the diameter of a round pin to fit the width of the center groove here. So that's how I hold it down, and that's how I keep it in line. This flat plate that's welded on the bottom side here is when okay, that locks it. You bolt it down here, and that locks it from rotating. It holds it perfectly in line with the table. But this flat bar right here, when I put rudders and things up here, I needed a surface so that I could support it with a screw jack, so I could hold the outside part of the blade off of both sides. You'll see that as it's going. The top here is a piece of angle to act like a V cup or a V block. And then I just tacked in lightly. Everything on this jig is minimum welding. Just stagger your welds and keep the all materials from going into a warp or making it, you know, you're trying to hold the tolerances of holding something as straight as you possibly can. So by using staggered welds and staggering them as I'm putting them on there, I'm able to go ahead and do this as a weldment. So I did, I cut and milled down a little bit on this leg of this angle, just because I knew that I was going to come in the one rudder. These two slots right here are for a true north rudder, which have a side fin on them, and this port here and this port here and these slots have to do with that Pacific rudder. But there's a lot of other rudders, and I'm going to show you how I do what I have in hand right now. And so anyway, I'm going to grab the hardware, which bolts that on, and I just keep these right on over here because this is I need these every time I need it. So why not just have a full set? So I have 4 T-nuts, so I don't have to take any of the other ones out of the rack. I got plenty of extra ones. And then these are the 1/2 by 1 inch threaded bolts with washers, and that way I never lose them. They stay right there. And then I just bring this in and I start out. Okay, once you got one in there, the thing holds itself up here, and then you can concentrate on getting the other ones in here. You know, most of the time when you make jigs, you build jigs with material that you have laying around, and it's more or less a consumable item. But I tell you, this jig I also use for a lot of other things. Let me see if I have. This is going to exaggerate maybe the diameter or whatever. In the marine trade, lots of times with some of the new fiberglass stern tubes and stuff like that, I do a lot of turning for stern tubes in the lathe with vacuums and holding steady rest and stuff like that. But sometimes there's a tube that's longer than my lathe, or I can't get it through the hole in the headstock or whatever, and I found that with having the long V surface right here, I can go ahead and clamp down my fiberglass tube, and I can come in the end, and I can do straight line bores into the end to hold the cutlass bearings and stuff like that. And if you wanted to, you could actually take and set your boring bar up so you can turn on the OD, and you can let it overhang, and you can do something like that. There's a lot of other uses for this jig than just doing rudders. I also will have a strut, and I bore struts in this at times. Sometimes I bore the struts in a vise where I have one wing coming off or one strut support coming down to the barrel, but I have one down here where I actually do use this, and I'll be showing you that as well. Okay, I'm going to move the camera around so you can see a little bit more. You say, okay, how do you zero up? And that's what we're going to do now, is we're going to zero up with this jig, and then after that, then I'll start mounting the rudder on it. All right, let me get this fired up. All right, now this is how I align the spindle to the jig, and I take this is a nice big Jacobs chuck. This is pretty good size one. It's 3/16 to 3/4. I got it on my number 40 taper. It's one of the first items that I made sure I had in this, because I had the K&T before I had a spindle mill, and lots of times I did a lot of drilling, and I would do it off the side. All right, now what we do is we take our favorite 3/16 double broken in mill, and I put it in there like that, and I go ahead and I put it in neutral so I can hand spin this thing. I go ahead and I bring the V underneath, but have enough room so I'm not hitting it with any of my jaws there. Then I bring it up. I have the table in free mode. There's no brakes on it, so I can easily go in and out, and I can crank it up. And what I'm doing is I'm cranking it up, and then I lightly move it back and forth to side until I get right down into the middle there, and I got a good feel that I'm side to side and I'm down in that valley. Okay, we're working with cast materials, so this tolerance that I'm aligning this to is putting this so that I'm vertical, or I'm horizontal in line with that V. So now I'm just going to set up my job, and all I have to do is worry about coming up to center line with the blade laying on its side. So I lock my table on the in and out, and I go ahead and I drop the table down and I move it back from the edge, and I'm going to pull this out, and I'm probably going to start with a center drill or a pointer. Sometimes I just take the pointer or my tap follower and put that in to align with the rudder blade. Alright, now let's grab a blade and I'll show you how I set that up on the jig. Okay, we take our blade, sometimes we lay it up here, sometimes we just stand it up, and first thing we do is we take our Dykem stick, aka Sharpie, and we put a pretty good blob of blue right here in the middle. And then we'll take our calipers and we come across here, and it's about 270, almost 2.3. So we come down here and we add 1.185. That's going to be close enough. And then we take and we use them as an edge scriber, and we can add a little bit more. We know that we're just a little bit shy. We'll try at 180. Actually, we need to come down a little bit. There we go. About 160. Anyway, we put two arcs that cross in the center and give us a center height location between each side. That is all we need to put in. Now, if we're doing a pintle, which you'll see a pintle on that end, we would be marking both sides. But right now, we're going to consider that center, and then we're going to consider center of this side here, down here, center. So we take our Dykem here, we know we're going to be close to this edge down in here. All right, and we're about 260, so that would be like 130. And we just give us a scribe down the center there. Now we're going to be scaling. We're going to be scaling this height here, and that's why we like to use our hundredths scale, and that really helps us get those two center. All right, I got to go get my jig kit that helps me with all my shimming and platforms, and also my screw jack for this side. Okay, I believe I got everything over here. This is a box of goodies, and this has spacers, V-blocks, and little round dowels, and we'll see some of that playing out through this whole thing. There's another key aspect, and I have a couple pieces of 3-inch channel just cut 3 inches long, and I use those for bridges over the boss areas to clamp down on, and we're going to physically C-clamp this into place, and that's how we hold our part. Okay, so these will come into play here in a minute. Okay, and I got my screw jack, and I don't know what height this is, but to get started, I put the rudder in here. I hold it back from the edge just a little bit, and I kind of get this in here. then I take my scale here, and I kind of measure it down at the bottom of the valley up to my center line, and I'm right around 1 inch 750. So I want the center of this over here. Hello, baby. Okay, back to where we were. I think we did that. Okay, we're taking our scale and we need to measure up to this. Now we know that right now we're about 1 inch 500, so we need to come up about 250 thousandths, a quarter inch. What I have to support down in here to get this to be up but still feel free, so that when this aligns itself to the V, this has to have a little bit of room to move here. So all we want to do is lift it. We don't need to locate this. This is going to locate the rudder. All right, so I have a couple pieces here, and this is 1.25 inches, this is 1.5 inches. I don't have 1 3/8 inches, which would probably be pretty close to it by that just fitting underneath there. So we got that set there, and we're just going to make sure. How close are we now? We're about 1 inch 550 or so. So it looks like we need a couple hundred thousandths to go. We'll just try a piece of 3/16 if we have that in here. That's a piece of quarter. That'll be a little too much. Okay, let's go ahead and we're going to slide an 1/8 of an inch in here. Let's see what we look like. Okay, about 1/650. See if we have another one of those. Okay, yeah, this is like a piece of 90 thousandths. Okay, we're right at the 750. We come back over here because sometimes when you lift that, you bring this down a little bit, but it's not moving down enough to make it matter there. All right. Okay, we're within about 10 thousandths as far as the height going by my scale, my quick scale. All right, now we're going to go ahead and put a block here. And the reason why I put those slots in there is any of the rudders, be it this or the rudders with the pintle on them, you still got to reach in here. So I cut that opening so I can get the foot of the Bessie clamp right in here. Now, before I tighten this down, I want to look at the horizontal plane here and grab okay, I grab a scale and I lay it across here, and I can kind of just glance at it, and I know that I want to go ahead and I want to pitch it up just slightly. So I take my screw jack, and it's like that.
Hi, how you doing?
All right, I got it horizontal in the line that I'm going to be comfortable with. It's narrower here than fatter here, so it's going to have some, this is going to actually slope that way, and this is going to slope down if it was perfectly in line or center, but that's going to be close enough right there. All right, I got this clamp in here. It feels good there. All right, now I bring my additional clamps in here. I grab a clamp there. I grab a clamp right on this point right here. Okay, I clamp all three of those. Now, what I usually do is I go ahead and I have another round piece that I set in here. Like that. And I put a couple extra clamps in here. Sometimes I actually put a crossbar in here, and I have a spacer or something that fills in on a couple of them. There's some of them actually fall right into place, and some of them don't. But I go ahead, and by putting these two extra clamps here, It just helps give a little bit of push. I run flat ground bits because this material is real grabby, so it has a little bit more of a tool pressure as far as the push, and that's why I have a little extra push in here. Now I don't run any coolant on here because I want this to get hot and I want it to swell, because when I get to the ream finish, I want that reamed hole to be hot, because when you pull out of it and you're all done with it, when this part cools down, that's where you pick up some of the press fit that you're looking for in this fit. Okay, put in our center, fire it up, bring it on over. All right, now we're just cranking it up and down until we get right in the center. And I like that. All right, now I'll get a starter drill. Okay, I'm just going to touch it a little bit because I want to basically see my touch looks good, looks in the center. Now, you'll see that it almost looks like the center's that way just a little bit, but that's the way this curve is. But the way it's sitting here and hitting here, that's where it's going to go, because we are riding and it feels good side to side here like this. Okay, I'm not going to try to put too deep a one in there. I'm just going to start off with a 3/4 inch bit, and we'll sink it down to the height we want. Okay, we're going to pull out our drawbar here. Now what we have here is the receiver collet for Morris taper number 4 to number 40 taper. Okay, so that'll fit into there, but we need to put the drill in. So what I do, I slip it in there and then I give it a tap on the butt. All right, now I need room to go in there, so we move this back. Okay, all right, that's about as fast as I go. Remember, I blunt the end here slightly so that it doesn't grab. And I bring this in, I plan my depth of my hole. Okay, I'm out to the outside edge. I see I'm cutting that diameter. Now I want to measure that depth. And I kind of that's the width of the drill is what I was pointing to earlier. Now I go ahead and I want to take my depth I'm going to cut, and this is how I gauge it. And instead of, you can do a lot of different things. I use Sharpies and marks and things like that, but sometimes I use the regular stop without setting it up to cam out the lock on the handle here. So let's just say I want to go ahead and put this in a 4-inch. I just eyeball the edge of the block with the edge of here at 4 inches, so that when that gets there and I eyeball it there, that's good enough. I'm going to stop right there. It's not rocket science. Okay, I'm going to put up 2 aluminum pieces here. I save bronze chips, so I try to keep them up on the table as much as I can. Sometimes they go down to the floor, but this helps hold them up here. All right, we're going to go down to the bottom with the 3/4, and then we're going to go to the inch and 3/16, and then we're gonna ream it out to 1 1/4 inch. Okay, we're bringing it down to where we're just at the flute's edge there, okay? Okay, we set our new depth. Different drill bits are different lengths, so you gotta set this each time. All right. There we go. Okay, we reached the end. A little bit more. Okay. We pop it out. Now this is an important thing. This is pretty warm. We want to keep that temperature in there for our process there. Okay. Also, too, I wanted to show you that this adapter has a knockout grab in it. So that's what I'm over here doing, is knocking it out. I use the edge of my press to do that. All right, and we slip in the reamer. Same thing. Okay, and while it's hot and it's not cooled down, we're going to take and hand walk our reamer in. We keep it at the same speed there at the drill bit, and we know how far this is going in. So we want at least that 3" there. Okay, we hold those depths pretty close because we pre-cut our stems exactly the length we want. Okay, now this is done. Now we can go ahead and heat shrink the stem into the rudder, and we're pretty much in a hurry to do this because Prue's going to come by and pick it up in about an hour. So we got to hop to it. Okay, we slipped it in there with the keyway aft after we had heated it up, and it slipped right in. And now it's grabbed a hold of it, and now we got the stem on there. Okay, now we're going to take it in. We're going to drill a couple cross pin holes real quick. It's not rocket scientists.